Welcome to Study Loop.
So for part A, let's use a computer algebra system to find the partial fraction decomposition. So I'll insert this fraction into a computer algebra system. So here's Wolfram alpha. We input the fraction. And then if we scroll down, we see a partial fraction decomposition. That's highlighted here. So let's go ahead and write all this on the whiteboard. So for part A, we can rewrite f as the following. So we do have a lot of writing here with the large numbers. So this is using the computer algebra system to give us the partial fraction decomposition. So there's one term. So then we have 668, 323, 2x plus 1. Also, minus 9438, 80155, and then we have one more term after this. So this is just for part A here. And one more term, 24, 110, 4879, 5x plus 2. Now the next part will be to actually go ahead and integrate this. So the first integral is going to be the most difficult because of the quadratic. So we'll have to go ahead and complete the square here. You can write this as x plus a half, square that whole thing, and then radical 19 over 2 squared. So we just completed the square there. Let's spend a few moments just on this first integral. The other three integrals will just involve natural log, and you could do them all by u substitution. So here, let me take this first fraction and then just go ahead and write this. So what I'll do here is, I see that I have an x plus 1/2 on the bottom. So I'll rewrite this x as x plus 1/2, but by doing so, I'll have to subtract. So we have 2, let me take a step back here. Let's do x plus 1/2. And then we still have the plus 48,000. Since I just added in this extra half, I have to make up for it by subtracting 1/2 of this number. And then now let me just split this into two fractions. I still have that 260,000 out there. And now after I completed the square, I have this, and then root 19 over 2, square that as well. So that's the first integral, and the same denominator will show up in the fraction. Got a little sloppy here. And then we could even put a dx up here because we're integrating. Now let's break this into two parts. So here we should take u to just be x plus 1/2 take it to be the denominator there without this number in the front. And then du over 2 is x plus a half dx. So that integral becomes and then from our u sub we have 1/2 1 over u. Oops, that's a u there. So this becomes, that's a 4 out there in the front, 4/9. Then we have natural log of u, and then we could replace u with x squared plus x plus 5, and let's put that in absolute value. So this right here is just ln of u, and I just replace u with the definition here and then simplified it. So that's the first integral. So remember on the previous page we had 4 integrals to deal with. We're just dealing with the most difficult integral here that we circled in red. We split it into 2 parts. We just found one of the parts. We'll add one more part to find, and then we'll simplify the other 3 simpler integrals. For this integral, let's do trig sub. So go ahead and evaluate this using this trig sub in the same manner that I did over here using the u sub. And this integral becomes 75772, 260,000. We have that 19 on the bottom, and then arctan, for this is from the trig sub, 2x plus 1. And then on the bottom, radical 19. So the first most complicated integral that we had, we just broke that into 2 parts. Now we also, so we'll just add those together at the very end. And then we had our second integral, 668 over 323, 2x plus 1. Feel free to do a u sub here. Then the next integral, the third one, oops, that's a 8. 80, 3x minus 7 dx. So go ahead and do u sub here as well. U equals 3x minus 7. You get 3146, 8011155. Natural log 3x minus 7. And then for the final integral, so here's our last integral, then we'll finally go ahead and add everything all up at the end. So go ahead and do a u sub here. V equals 5x plus 2. And simplify this integral to get natural log (5x plus 2) in the absolute value. And now the final answer is just the integral, the sum of the 2 integrals that we had on the previous page, then minus this integral, minus the green integral, and then plus this last red integral. So let me go to the next page to write that. So our final answer and then after we write this down, we'll go ahead back to Wolfram to the computer algebra system. and we'll see if there are any differences in how our final answers look. My guess is that they just won't have absolute value inside the natural log. And we'll check it momentarily. Let's keep writing this answer down. Just adding and subtracting all these integrals together. So that's the sum, that's the most complicated integral. That's where we have to use the u sub and then the trig sub. Then the next integral. And then we subtracted the following integral as well. So that's 80,155 ln 3x minus 7. And then the final integral we added, that was 4822. So this is our last expression here. Natural log 5x plus 2. And finally, we could go ahead and add in a constant of integration c. So this whole page, this whole whiteboard is our final answer. And let's go ahead and compare it to Wolfram. So note the constants. Note also we have absolute value here for all of our logs. If we go back to Wolfram, our computer algebra system, let's scroll down, and it gives us the indefinite integral of our fraction. It just writes it in a different order, but it is the same fraction. And if you look inside the logs, here by log they mean natural logarithm as they mention on the side, but they do not have absolute values. But otherwise our answers are the same. So that's our final answer.